Hello everyone, welcome back. So in our last session, we have discussed why subnetting is needed. So now we will do classy subnetting. Okay. So as we discussed in class in our last session, uh, I have three departments: Department A, Department B, Department C. In Department A, there are 50 users. In Department B, I have 30 users. And Department C, I have 10 users. Without subnetting, if you take one network for Department A, like 192.168.1.0 network, and Department B, 192.168.2.0, and Department C, 192.168.3.0. This network range is 1.255. This network is 2.255. This network range is 3.255. So every network provides 254 IPs. First IP, last IP. First IP is network ID, last IP is broadcast ID. So those two IPs are reserved for network ID and broadcast ID, right? First IP, last IP. So here we have 254 IPs, here we have 254 IPs, here we have 254 IPs. But this is not a good thing, right? If you use like this, it is not a good thing because we will lose more than 600 IPs. Here we will lose 204 IPs, here we will lose 224 IPs, here we will lose 244 IPs, right? Without wasting IPs, if you want to connect these three networks without wasting any IP, we need to do subnetting. But if you want to do subnetting quickly, we should know these two tables. We should know these two tables here. This table is very, very important, and this table is also very, very important. So here 2 power of 0 equal to 1, 2 power of 1 equal to 2, 2 power of 2 equal to 4, 2 power of 3 equal to 8, 2 power of 4 equal to 16, 2 power of 5 equal to 32, 2 power of 6 equal to 64, 2 power of 7 equal to 128, 2 power of 8 equal to 256. You should remember this. And here, this is one more table. This is also very, very important table. See here 128, 64, 32, 16, 8, 4, 2, 1. From right to left to 1, 2, 4, 8, 16, 32, 64, 128. Now see here 128, 128. 128 plus 64 how much? 192. So 128 plus 64, 192. And 224 means 128 plus 64 plus 32. Okay, if we add these three, you will get 224. And 240 means 128 plus 64 plus 32 plus 16. This 4. And 248, the first 5 up to here. 256 is right this one. These values are very, very important. Very, very important. These two tables are very, very important. Now, we will do subnetting. Okay. So here we have three departments, right? Department A, Department B, Department C. In the Department A, we have 50 users. Department B, we have 30 users. Department C, we have 10 users. Now, total how many IPs are required here? 50 plus 30, 30 plus 10. Total 90 IPs we required. That's it. So now for we require only 90 IP sites. So I will take only one network from class C, 192.168.1.0 network. This is the network, right? Because this network range is 1.255. So these IPs are enough as per our requirement, right? But actually my requirement is what, 90 IPs only. For these three departments, we requirement is only 90 IPs. But this network provides 256 IPs, right? More than enough. So take only one network and divide this network into these three departments. For these three departments, how to divide this network? Now, before that, I will give one more thing. What is the default mask of this network? The default mask is 255.255.255.0. This is decimal subnet mask. This is decimal subnet mask. 255.255.255.0 is a decimal subnet mask. This mask can be written as /24 like this. So like 192.168.1.0/24. So /24 represents network bits. Any value, if you see after slash, that number represents network bits. That number will not represent host bits. Whenever you see after IP address /value /24/25/26, whatever it may be, okay, whenever you see that number represents network bits. So 255.255.255.0 and /24 both are same. So here also we have a 24 network bits. Here also we have a 24 network bits. This is decimal subnet mask, but this mask is CIDR mask, classless interdomain routing. Classless interdomain routing. Classless interdomain routing. 192.168.1.0/24. /24 is CIDR value. /24 is what? /24 is network bits. 24 network bits means in this IP address we have 24 network bits. Remaining bits are what? Host bits. So total IPv4 address length is 32 bit address. In these 32 bits, 24 are what? Network bits. So 32 minus 24 how much? 8. So remaining 8 are what? Host bits. Very simple. Here also same meaning. 255 equal to 8 bits. 255 equal to 8 bits. 255 equal to 8 bits. 24. Remaining all are what? Host bits. Right. So now we will do subnetting as per this requirement. The first we need to find out what is the highest requirement. Based on the highest requirement, we will do subnetting. So here department A require 50 IPs, department B require 30 IPs, department C require 10 IPs. What is the highest requirement here? 50 IPs. 50 IPs is highest requirement. So based on the 50 IPs, we will do subnetting. Not based on 30, not based on 10. Remember this point. This is the first step. Whenever you are going to do subnetting, the first we need to find out the highest requirement. Based on the highest requirement, we will do subnetting. We will do subnetting. So what is the highest requirement? Highest requirement is the 50. Right? So now 50 IPs, right? But here we cannot take exactly 50 IPs. We cannot take exactly 50 IPs. We cannot take exactly 50 IPs. So we should take IPs based on these numbers. Based on these numbers. What is the nearest value here to 50? The nearest value is 64, right? So actual requirement is 50, but I can't take 50 IPs. So we should take 64, or we can also take more than 64 also. 64 means 2 power of 6. 2 power of 6. Remember this point. Very, very important. 50 IPs, right? 50 IPs means 50 host. Here see, if requirement is host, we have to borrow bits from right to left in host portion. We have to borrow bits from right to left in host portion. If requirement is host, we have to borrow bits from right to left in host portion. Right to left in host portion. So right to left means what? This is the class A network, right? Now we are discussing class A network, right? So network is what? 192.168.1.0/24. I want to divide this network, right, for these three departments. Department A, Department B, Department C. Department A 50, Department B 30, Department 10. So highest requirement is a 50. So right, we are doing subnetting based on the 50. 50 means we are taking how many? 2 power of 6. 64 IPs we need to take. We cannot take exact 50. Remember this point. We cannot take exact 50 IPs. We should take 64 or more than 64. So right, 2 power of 6, right? Now see here. This is the network portion. This is the network portion. This is also network portion. This is the host portion. So we cannot do anything on network portions. Remember this point here. In first three portions we cannot do anything. The last portion, right? In the last portion, how many bits are there? In the last portion, we have 8 bits. See, first to open these 8 bits. 1, 2, 3, 4, 5, 6, 7, 8. Like this. This is the fourth portion. This value is 1. This value 4. This value 4, sorry, 2, 4, 8, 16, 32, 64 and 128. This is the which portion? This is fourth portion. Remember this point. We are in fourth portion. First portion network portion, second portion network portion, third portion network portion. We cannot do anything here. So in the fourth portion we have 8 bits. So to meet our requirement, what is our requirement? 50 IPs. 50 IPs means how many IPs we need to take? 64 IPs. 64 IPs means 2 power of 6. So we need to count from right side to left side. Okay, right side to left side. How many bits we need to borrow? 6 bits. 1, 2, 3, 4, 5, 6. Just count 6 bits. Up to here, host bits. These are host bits. Remaining 2 are network bits. This is step 1. The first we need to find out highest requirement. So based on the highest requirement, we need to take IPs. So here highest requirement is the 50. 50 means we need to take 64 IPs. 64 means 2 power of 6. So this 6 is very, very important. So now here we need to borrow 6 bits from right side to left side. Okay, from right side to left side. Okay, count 6 bits. Okay, 1, 2, 3, 4, 5, 6, like that. Remaining 2 are what? Network bits. The second step is find out block size. Find out block size. What is the block size? 64. What is block size? 64. Block size means least value in network bits. Least value in network bits. Least value. Smallest value in network bits. So here what are the network bits? 128 and 64 are network bits, right? So here what is the least value? 64 is the least value. 64 is called what? Block size. I will tell you what is the use of this block size. The third step is find out customize subnet mask. Customize subnet mask. What is the customized subnet mask? What is the default mask for this network? This is the class C, right? So the default mask is 255.255.255.0. But now, what is the customized mask? See here. The customized mask is 255.255.255. How many bits are there? Network bits? Two network bits, right? 128 and 64. So we need to add these two, 128 plus 64. So the value is 192. These 192 tells, these 192 describes in the fourth portion, there are two network bits. This is customized subnet mask. The last fourth step is what? Find out CIDR. Find out CIDR mask. The CIDR mask is /26. What is the CIDR here? By default 24. Now we converted two bits, right? 128 and 64. So 24 plus 2. 24 plus 2. 26. This is the CIDR. The CIDR nothing but number of network bits. By default we have 24 network bits. Class C, by default we have 24. 24 plus, now we converted 2 bits into network bits, right? So these 2 plus this 24, total 26. CIDR. The last step is find out subnets. Find out subnets. Subnets means small networks. Means if you divide this network 192.160.1.0 network into 64, 64, 64, right? We are doing subnetting based on the 64, not a 50. Right? If you divide this network by 64, 64, 64, how many networks we will get? Small networks. So how many network bits are there? 2 bits, right? So find out subnets 2 power of 2. How much? 4. Total 4. So we will get 4 subnets. Okay. I will repeat one more time in notepad file. So see here, I will write everything here. So I have 3 departments. I have 3 departments. The first one is department A, 50 users. Department B, 30 users. Department C, 10 users. Right? So here, the first we need to find out total how many IPs we require. So here for these 3 departments, we required 90 IPs. That is a step 1. Okay. So we require only 90 IPs, right? So 90 IPs means we can take one class C network. So I am taking network 192.168.1.0/24. This is the network. This network provides how many IPs? This network range is 192.168.1.0 to 192.168.1.255. But here range is 192.168.1.1 to 192.168.1.254. This is actual range. Now, right? So now we need to use this network for these 3 departments, right? Department A, Department B, Department C. I want to use this single network for these 3 departments. So here, the first we need to find out the highest requirement. What is highest requirement? Highest requirement is 50. Based on the 50, we will do subnetting. So 50 IPs means we need to take 64 IPs. 64 IPs. 64 means 2 power of 6. 2 power of 6 equal to 64. So to meet our requirement, we need to borrow 6 bits. Okay. So now here, this is the class C network, right? So class C means this is the network portion. This is the network portion. This is the network portion. The last portion is the host portion. This is host portion. Now do here. Now in the last portion, we have 8 host bits. 1, 2, 3, 4, 5, 6, 7, 8. The first we need to open these bits. This is the 128, this is the 64, this is the 32, this is the 16, this is the 8, 4, 2, 1. Okay. First we need to write like this. This is fourth portion. Remember this point. Because we are doing subnetting on class C. In the class C, first 3 portions are network portion. The last portion is the host portion. In the host portion, we have 8 bits. First open this 8 bits and write values like 1, 2, 4, 8, 16, 32, 64, 128. Now how many bits we need to borrow? 2 power of 6. 2 power of 6. So from right side to left side. Okay. So from right side to 6 bits. Okay. So these two are what? These two are network bits and these are host bits. Count from right to left. Okay. Right to left. That is very, very important. So here to here. Okay. Here to here we need to count 6 bits. So 1, 2, 3, 4, 5, 6 like this. And the remaining two are what? Network bits. Remaining two are what? Network bits. Okay. This is the step 1. The step 2 is find out block size. Find out block size. What is the block size? Block size is 64. So here 64 is least value in network bits. What is the least value here? 64. So here these two are network bits. So here smallest value is the 64. That is called what? Block size. Second point. Next point. Subnet mask. Customize subnet mask. What is customized subnet mask? The default mask is 255.255.255.0. This is the default mask. But now in the fourth portion, we converted these two into network bits, right? So that's why here in place of 0, we need to put 192. So 128 plus 64. We need to plus these two. So whatever we have a network bits, we need to plus. That is subnet mask 192. Remember this point. Next point. CIDR. CIDR is /26. Why /26? 24 are default network bits and 2 are our converted network bits. Total 26. So here 24 is there, right? By default. Now 2 bits. Total 26. Now subnets. How many subnets? So total how many network bits are there? 2 power of 2. Okay, 2 bits are there, right? So 2 power of 2 equal 4 subnets. That's it. Subnets is nothing but number of small networks. So we are doing subnetting based on the 64. Network is 192.168.1.0/24. We are dividing this network by 64, 64, 64. If you divide this network by 64, 64, 64, we will get 4 subnets, 4 small networks. Okay. Now I will create 4 subnets. The first subnet is always 0, 192.168.1.0. The second subnet is, so here we need to increment block size. What is the block size? Block size is 64. So we need to increment 64, 64, 64. Okay. So second one 192.168.1.64. The third one 192.168.1.128. Fourth one 192.168.1.192. That's it. 192 is the last one because our mask is 192. We need to stop there. So total how many networks are there now? Now we have 4 subnets. The first subnet is 0. Second subnet is 64. Third subnet is 128. Fourth subnet is 192. So first subnet range 1.0 to 1.63. Why? Because second network started with 64 and second network last IP 192.168.1.127 and here 192.168.1.191 and here 192.168.1.255 and here uh, this is network ID and this is broadcast ID. And what are the first IP? What is first IP? First valid IP and last valid IP. The first valid IP is 192.168.1.1. The last valid IP is 192.168.1.62 is a 62. First valid IP is 1.1. The last valid IP is 192.168.1.62. Because 63 is a broadcast IP. We cannot use. So before 63 we have 62, right? So 62 is our last valid IP. So here first valid IP is 1.65 and here 192.168.1.126 and here 192.168.1.129 and here 192.168.1.190 and here 192.168.1.193 and this one 192.168.1.254. So first subnet 1.0, second subnet 1.64, third subnet 1.128, fourth subnet is 1.192. So I will assign first subnet department A. Department A. I will assign second subnet department B. I will assign third network department C. Total 3 networks. Right? So this is how to do subnetting for 50 IPs. For this all networks, subnet mask is same. Subnet mask is same. For this all networks, subnet mask is 255.255.255.192. Here also 255.255.255.192. Here also 255.255.255.192. Okay. So again, if you have any doubt, please ask me. So if you have any query or if you have any question, please write your questions in comment. So I will try to clarify your doubts. Okay. So in the next session, we will do subnetting based on 30 IPs. Okay. This is based on the 50 IPs. Okay. So we will meet again in the next session.